The company over the last several years, including the acquisition of a company called SoftLayer, which is one of the pioneers in the whole space of cloud computing. And our audience that comes to CloudEXPO every year is a mix. We've got developers, we've got managers, and we have architects, we have CIOs. Harold Hannon from SoftLayer is an architect, a senior architect, and he's going to come up and talk a little bit about what they're doing and what it means to you. I think we're loaded up. Harold Hannon?
Well, this is it. Okay. This is the evil clicker of death, everybody.
So we need to recharge it, I think. One of the great things about technology is it never causes a problem.
Never, ever, ever.
The simplest things.
Yeah. You guys aren't in luck. I don't know how to tap dance. I will say at some point, this is going to be probably one of my more nerve-wracking presentations because my wife's here somewhere, so don't be offended. You guys are important too, but this will be the first time I have a family member in the audience, so hopefully I do pretty well up here. You guys don't throw too many tomatoes or anything. There we go. All right, now we're ready to go. So my name is Harold Hannon. I work for SoftLayer. We just got acquired by IBM recently. I say recently, it's probably more like a year and a half, 2 years now. And I'm an architect with them, so I spend a lot of time with new technologies, doing innovation type work, looking for new products. So I get to play with a lot of new toys, do a lot of research work. It's a lot of fun for me. You know, maybe not everybody's into doing research, but when you get to play with new toys, it's fun. So hopefully I can share a lot of that experience with you today. This is kind of who we are. SoftLayer is an infrastructure company. So we provide all of the tools and guts and gears that a lot of people use in the industry to actually build very cool, interesting products, right? So like I said, one of my jobs is to go out there and figure out what it is that you're building, what the new things are, and how it is that we can help facilitate that, right? Because we're in the business of providing that infrastructure. So this is one of the marketing slides that we have that sort of shows the different layers. We've got the web, we've got the mobile access, the API, all layered on top of that very important sort of infrastructure layer. We have what we call a pod concept, so the way we build our data centers, and pod groups, sort of a cookie cutter template, makes it very efficient for us. Very easy for us to do. And then obviously we have a very robust network underneath of that. And we have our own internal systems. So this I like to call my birthday slide. The reason I call it my birthday slide is IBM, when they first acquired us, they liked this whole concept of the data center and the pods, and they pumped $1.2 billion in on my birthday. So true or not, I like to say that they did it for my birthday. It was my birthday present. To expand the data centers. So obviously we're ever expanding globally, have a huge footprint. So now that you kind of know where I'm coming from, I'm going to talk a lot today about different tools, different technologies that we provide for you to build all of your cool, interesting applications on top of it. So there's a lot of different deployment options that we have. So I'm going to kind of go through some of the product research for that. And it's going to be more of kind of like a supporting argument for what tools that you use for what purposes. And then kind of give you a little bit of a cost model sort of thing to let you understand exactly some of the decisions, what that means to the bottom line when you actually apply those tools and technologies. So kind of run through all that infrastructure, how it all fits together, and what works where. So it used to be, I've been coming to this expo for several years now. So it started off with people up here and in the breakout sessions explaining what cloud was, you know, when it was a lot of just virtual compute, things like that. Now we're sort of getting to the point where the cloud is becoming this giant pile of tools. We have a user experience employee that works with us. He's a pretty colorful guy, and he's always saying that we shouldn't sort of just throw up our tools on the table, hey, here's our tools, we need to do better about actually presenting them in a cohesive manner. Actually, he doesn't use the word throwing up. Like I said, he's colorful, but sort of this is what it's become. It's become all these different as a service. We've got the workflow, the monitoring, all these things. Everybody's piling on all this value add. But really, when you get down to it, all the roads still lead back to a compute of some kind. Arguably bare metal, if you really, really want to get right down to the very base. But in reality, it's all just compute running underneath of all of those things. So for an infrastructure provider like ourselves, we have to be the best at doing that. That way we can layer things on top of our compute services as well as our customers, people like yourselves, that can layer on top of that base. So we really, really need to be good at choosing those base products, being able to put that infrastructure layer underneath of what goes on top of it. So this is kind of what it boils down to these days. You've got your basic, everybody knows the virtualized cloud environment. I think we're all very, very familiar with that by now. You obviously have the bare metal, which previously was only available as a physical server. But now we sort of have these, what they call bare metal clouds, where you sort of have a lot of the image-based solutions and the APIs and some of the niceties of the virtualization with the single tenant offerings. And then obviously everybody loves the whale now, right? The whale's the talk of the town. So you've got your containers and Dockers helping to enable that. And so it's kind of come along and it's starting to show up at the service providers as well. So we've kind of got this layered strategy. So this diagram kind of shows the stack, and I know I can see a couple engineers out there grimacing, and he doesn't know what he's talking about. Containers don't go on top of virtualized hypervisors or anything like that. Sometimes, and we'll get to that. And then obviously at the bottom you've got bare metal. So let's kind of talk through those different layers. We'll start at the bottom because... So if you're not familiar with the bare metal offerings, just a level set, obviously it's sort of a build to your own specs. You've got a lot of control over your hardware, right? So you're able to sort of pick, I want this specific processor, I'm looking for GPU, I don't want to pay that 2 to 5% hypervisor tax. I don't want anybody else on that machine with me. I want to know exactly what's going on. Really great for data type solutions, databases, any of your sort of NoSQLs, big data solutions especially. Anything where you've got a lot of IOPS, a lot of I/O, you want a lot of control, right? Those are really the best use cases for these types of offerings. And then public cloud, that's what we're all here for, right? The CloudEXPO, right? So this one is really, really good, and a lot of the providers in the space, including ourselves, we've all sort of trained everybody now to lots of little, lots of bursting, right? So only when I need it, when I want it. If I need some more, suddenly, I just got a lot of traffic. I'm going to burst up. I'm going to compress back down again. I only want to pay for what I want. Great for those types of things, web heads, anything that's going to take a lot of CPU and memory bandwidth and utilization. Great for those, great for development, but there are certain cases when you have something that's going to have a lot of I/O load on it that you probably don't want to find yourself using this sort of solution. A lot of times you can really fall on your face and get a little bit more into that, specifically some of the cases. And then obviously you've got to look out for some of the tricks, right? So no longer are you just getting that specific unit that's your single tenant sort of offering that's yours. You can have all sorts of oversubscription, clamping, all sorts of games that a lot of providers play to be able to squeeze that last dime out. So you really got to be careful of what platform that you're actually on. And then, like I said, the whale. Everybody's in love with the whale. I'm in love with the whale. So it's basically a kernel-based, if you're not familiar with containers by now, hopefully you are. If not, you should probably get familiar with it. It's a pretty exciting space right now. It's basically just a kernel sort of segmentation, right? So Generally speaking, we're not talking about a hypervisor. We're talking about some clever use of C groups. So being able to actually isolate specific executions and processes. So that way it sort of gives you a little bit of segmentation. But I kind of always keep I said something about the hypervisor and engineers getting mad because I said it was layered on top of virtual. Most often, if you do multi-tenant, if you told me the only thing between me and you on the same machine was C groups, if you don't know anything about them, that would make an architect like me a little nervous, especially if I have a lot of compliance or privacy needs, things like that. So a lot of your multi-tenant vendors right now, what you're getting when you get a Docker container or a Linux container offering is you're getting a virtual machine with containers stacked on top of it. So you kind of lose some of that bare raw compute resource that you were going to get by just having that container sitting on top of your bare metal resources. So kind of be careful with that. I mean, it's still great for cross-cloud platform deployment, so there isn't any more worries about whose image works with what. It's still all just container-based images and deployments, so you can manage across clouds easily. So that makes it very nice, but you may not be getting quite the performance increase that you would over a normal VM because it's, in reality, sitting on top of a VM for the most part. So let's talk a little bit about, now that we have those, the right tool for the job. And I see a lot of mistakes made when you sort of take these things and you start to apply them if you don't know exactly what you're getting into. So it really comes down to the platform, right? So how do we, as infrastructure providers, offer you these tools? Right, so if you sort of know a little bit about how we're putting them together and sort of where we decide to actually use these different technologies, then it helps you make the right decisions as well. And obviously, I'm going to run through a couple of these really briefly. I have a lot of breakout sessions I do on each and every one of these at a lot of different conferences. But mostly we're going to talk about sort of the OS, the hypervisor, different media types, the different file systems you can have, and then obviously a little bit about your vendor, right? So not all of you, I'm sure, are actually hosting your own data centers, so you're probably consuming a vendor. So I'll give you a couple tips and techniques for actually choosing which vendor you want to go with. And obviously, I hope you choose us, but you don't have to. You don't have to. So make a wise decision, right? So a lot of these things, they don't really cost you any money necessarily, right? So a lot of times everybody assumes if I need, more, I need to spend more, right? So sometimes you can work smart, not hard, and you can sort of make a good decision rather than just throw a lot of money at a problem. And these obviously have their own specific niches that they fit into as far as which actual deployment type matches the application space or use case that you're looking for. So don't just assume that you can just start throwing the applications out there onto any of these and they'll behave exactly the same. All right, so everybody don your 3D glasses at this point. This is a operating system icon that I put together that was a little bit of fun, but so we have a test. This was actually one that I had a CTO have me put together, and it was the result of a sales call, and they said, and I'm going to brand X everybody, I'm not going to tell you who the competitor was. I like to play nice. So they said, your instance isn't performing as well because you don't have the right hypervisor. There was an argument between HVM and paravirtualized hypervisors, and I went through and I started doing a study really quickly. And this sort of highlights, if you look down on the bottom on the green, that was our competitor, and then along the bottom we had a 1 CPU by 4 gig, and then we did a 2 by 8 and a 4 by 16 instance. And we use Unix Bench, which if you're not familiar with Unix Bench, it's sort of a yardstick for measuring aspects of a system. It's used quite often. And what we found was Ubuntu was the operating system of choice, and they were doing a 1 by 4, for instance. So on the low end, they were right. Our competitor was performing a little bit better. But the interesting thing was, by running the exact same test, and no offense against the people at Canonical, they have different use cases for different things, but just by switching to Debian, which oddly enough Ubuntu is based on, we suddenly got a huge burst of performance out of that exact same platform. So when we ran the tests with the two operating systems, radically different results, almost 3 times the results. So when you get into things like operating systems, and like I said, there's so many things we could get into. There's an entire talk on just this alone. The drivers, kernel modifications, there's so many things that go into the actual operating system. You think of how complex they actually are. Sometimes the selection of the correct operating system for the application and the platform can make a world of difference. And like in this case, maybe some time just to do some research, not a huge expenditure. And you can see clearly that there was a huge impact on the performance of that platform. So the operating system does make a difference when you're picking your deployment. And then sitting right there with it, obviously, if you're on a cloud platform or virtual guest, something like that, the hypervisor, right? So there's para-virtualized, there's HVM, the hardware virtualized, KVM, kernel over top the HVM. So there's different ways that we actually can slice up those machines. And obviously, para-virtualized is sort of like a software virtualization over top. The hardware and the KVM virtualizations are sort of built down in low-level instruction sets at the hardware level. So you'd think when you hear that, well, I don't want that virtualized thing over top because it's in the software. It probably doesn't perform as well. Incorrect. There's, once again, I'll show you 2 quick slides. Depending upon what you're doing, like in this case, bandwidth, we ran some tests using Ubuntu, and lo and behold, the para-virtualized options with the drivers that were built into Ubuntu, and once again, we're talking about how these systems actually implement these things. Everybody does it a little bit different. You can see that wasn't the case. So you're like, oh, well, we should use para-virtualized every time. Not so fast. Here's another example where obviously the hardware virtualization worked exceptionally better. So once again, it's a good idea. There's plenty of documentation on these sorts of things to actually get in there and look at what your hypervisor is actually capable of doing and what's the best selection for you. So let's get into the media types, right? Everybody's favorite, right? The disk drives. It's the most exciting part of a system, right? Selecting your disk drive. So this is an interesting little test. It's sort of a scatter diagram. And what we were doing here was we were testing REOC rings. So if you're not familiar with it, Basho makes a big data solution. If you take a look at the top diagram shows a network-attached virtualized instance, typical public cloud type offering. And as you can see, it doesn't really give you any idea. I mean, there's a blue line that's kind of through there that shows the average, but the only reason why it's there is because that happens to be the average. The scores we were getting were all over the board. Whereas when you put it on, obviously, a local disk SSD type offering, you can see it almost draws a complete straight line there. So you get a nice, consistent performance out of it. Every now and then maybe the public cloud would burst a little bit high, but when you're dealing especially with something like a data application, it's important to know when to scale, those sorts of things. So it's better to have an idea that if there's something going on in that curve, that it's you and not the way the wind is blowing in the cloud that day. So media really does play an important part depending upon the application. Obviously, if you're not too dependent on disk I/O, this sort of thing really isn't going to bother you. All right, so even more exciting than the disk drives, right? We have the file system. This was another interesting test we were doing, and since we're talking about disk stuff, I mean, we've got to do a data application, and we're going to give everybody fair play. So MongoDB. So what we had here was we had sort of an SSD-backed instance that was a bare metal server there in the red, and then we ran a public server, cloud virtualized, same thing. You remember it had all the sort of scattery, sort of cloud of bees looking display on the last one. So if you look at it, right around 16 to 32 concurrent clients you get saturation. This is a box and whiskers graph, so you can see that those up and down lines, that's showing you sort of the range of readings we were getting. So it's obvious when you get to about 32 concurrent clients or so, that's about all that attached disk is going to handle. It's saturated, it's not giving you any more, it flatlines, and your readings start going all over the place. The interesting thing, though, is along the top, if you look, the SSD is doing something really strange there. If you look at about 64, actually even about at 32, somewhere in between there, we start to flatline as well. But in the box and whiskers graph, you know, you're not really seeing a lot of wiggle there. So something was really, really strange there. Turns out that when we looked into it, it was the file system. Everybody loves sort of the ext3s and ext4s. It's what, you know, you install the Linux operating system. It says, do you want one of these too? Yes, I'll take one of those too. But those weren't designed with SSD in mind. So you get sort of a queuing problem. A lot of those back-end data files that these data applications use, they don't really lend themselves well to that sort of high concurrency and with SSD. So you get a little bit of a queuing mechanism. By simply moving to something like an XFS is what we did. There's ZFS. There's several other more modern file systems that were built with SSD around and with solid state type and flash media in mind. All of a sudden it opens up that sort of queue and lets more concurrency through to those data files. And you can see right there, the dotted line was where we were. Just by simply changing the file system, all of a sudden SSD starts performing like you would expect it to. And once again, we start to see a little bit of saturation at 128. I'm sure we could have pushed it a little bit further. So let's talk a little bit about the vendor platform. And this is sort of how we present things to you, right? So sort of what do we offer when you come to us? Once again, I'm going to be nice. I'm going to blur everybody's names out. This is once again Unix bench, so higher up is better. You want to have sort of a consistent flat line. I will say that the top 4 lines there all are home-based in the Dallas, Texas region. So, and they're not all us. But when you take a look at it, it sort of just shows general for context for the next couple slides. Generally speaking, this was a micro instance, 1 CPU, 4 gig of RAM. So you sort of look at where everybody lies. You know, there's a large group around the 600s, and then you get everybody else up by 1,000, right? So just a general sort of where the market sits. Now let's take a look at actually when you load these things up. So one of the things we like to do is we like to test, you know, how much can we push this? And this is about that oversubscription, the clamping, those sorts of things, right? So it's sort of a sizing game, right? So how many can we pack on our host before we start to negatively impact you as a customer and what your product looks like? So this kind of gives you an idea of the range of say we packed 30 VMs, then we moved it to 40. You can see if you had 50, you're probably down in that 600 range again. So this is just a game of packing. Now let's compare that, right? So this is the public cloud, the hypervisors. Everybody's piled on a machine together. Let's look at containers then, right? So what does that look like? So if you remember, you know, we were scoring around 1,000, 1,200. So if you take a look here, the containers, you know, you're multi-tenant again. You've got a little bit of segmentation. Now the scores look a little bit better. So, and actually we've packed quite a few more guests onto there. So whereas we were, you know, maybe at 40, if we'd have gone closer to 50, we would have dropped, you know, far below any of the market that was out there. It was about 500, 600 on that market study slide. So not a spot that you'd want to be in with virtualization, but we got a lot more density out of containers. But once again, you have to be careful because we can't really give you a container raw. Usually we have to pile it on top of a virtual machine. So probably not a great use case for ourselves. We're probably still stuck back as a service provider with 30 to 40 with a container sitting on top of a virtual machine. And then let's just take that same machine. So this has all been on the same basic host machine. And you can see with a bare metal instance, now all of a sudden we've jumped way up. We're by 1,750, 1,800 versus around the thousands, you know, or the 1,300s for the virtualization or the containers. And to be fair, if you take a look at that, I sort of jostled with the scale on there so you could kind of see the range. This is actually on the same range as that original market study slide and then the containers slide. So we got the 0 there. So you can see it makes a really nice tight little line there for the containers. Not a lot of wiggle in there. And actually the story gets better, obviously, with bare metal. So don't really get too excited and say, oh, well, we all need to do bare metal. You know, obviously we get the most performance for it. There's so many great things, obviously, with bursting. You know, you're not going to burst a bare metal instance for a couple of minutes or anything like that. So once again, just keep in mind everything has its place. Okay, so let's have a little fun. Everybody want to have fun? It's too early for fun? Okay. We're going to form a corporation today. It's Expo Inc. And our motto is going to be more for less, more or less. How many people want to be executives in our new corporation? Oh, too slow. Okay, you guys are all going to get all the preferred stock options. The rest of you guys, forget it. You're going to get diluted right out of the public offering. Okay, so let's say we're going to make ad services, right? Our fictitious app is going to be ad services. We're going to search for tickets. We're going to, oh wow, that's the wrong slides, but no more than 100 requests per second per client is going to be our throughput. And we must handle 128 concurrent clients at a time, right? So we're going to be serving ads to them. And our relative range, that box and whiskers that we had, the range of the readings, those need to stay within about 125%. And I put that in red because as your architect, all of the executives that raised your hands, you should probably fire me right away for that, but I'll show you why I did that in a minute, because we're going to kind of illustrate what it looks like to do something completely wrong. So we're going to serve up all these ads, and like I said, it's very important that we get it there very quickly. Anybody that's done sort of ad serving, you got to make sure you get them up there quickly and get them, a lot of them up there. You got to be able to figure out what ads go where and get them in place, right? We don't have a lot of money to spend, so we didn't go for the SSDs, right? No Ferraris for us. You know, we're gonna kind of keep it a little bit cheaper, a little more affordable. So we've got a SaaS offering that we're looking at, and then we have just a general virtualization. So if you remember when we were looking at those numbers before, we're going to use those as our base for the model. And you can see kind of where they land. But, you know, the public cloud's a little bit cheaper, so maybe we can get away with it. So this is going to be the basis. We've done these tests. We've looked at things. Let's take a look at the model. Our instance types, fairly comparable. Kind of keep as apples to apples as we can get. So let's take a look. With one client attached to us, we got our first client. Yay! Made our first sale. Operations per second, 219 on the public cloud, 542. Relative range looks good. We're looking happy. Two clients, ooh, a little bit out of tolerance there. The relative range, it's starting to swing around a lot. The ads are serving sometimes fast, sometimes maybe a little bit too slow, but you don't know it's the cloud, right? So as your architect, I'm going to tell you, hold on. Let's see what happens. Maybe we're just having some noisy neighbor effect on the cloud. Four clients. Okay, we're back in range again. All right, we're still doing good. 119 operations per second, 260 on the other side. Okay, so we're looking good. Oh, now that we got our 8th client and they're all attached and we're serving ads, okay, now we're clearly out of range. So we've had our first sort of scaling event, right? So now all of a sudden, that cost savings that we had, now all of a sudden we've jumped up. It's 2244 versus 1419. You know, and this continues to get worse as we double our load. Double it again. We're still doing good on the bare metal side. Now, mind you, like I said, this specific case was for big data applications. So we're sort of backing all that data that we're doing all that ad serving with it. So it isn't until we get to 64 on those model numbers that we put together that we actually have to scale up on the other side, right? So it's starting to look pretty clear to me. And like I said, every time you double it, you double your load. You have to double your capacity on the back end with that model. Now, if we had gone with the bare metal, $56.76 is our final monthly bill versus $35,000 on those cloud instances. So you can see making the right decision on the right platform can have a massive effect. Please don't do the I must buy a virtual guest, you know. They're good for certain things, right? So if this was a web server application, you know, we could sit there and say, okay, well, if we burst here and we, you know, don't burst on the bare metal side, this picture radically changes. But this is an example, data application, so much better suited to the bare metal applications. So in summary, using the right tool for the job is very, very important. Tens of thousands of dollars a month in this case that I just showed you important. There's a lot of options out there, right? So, you've got to actually take a look at what's available, what we provide as a provider, and know what you're getting into, right? So know what we're using, talk to your vendor, understand which hypervisors we provide, which operating systems we have in our image libraries, test them. Don't just make a guess. Don't just trust what we're saying. Try some different operating systems. And finally, the answer isn't always more iron. Sometimes it's just the right iron. So make your decision wisely. Okay, that's all I've got. Thank you very much. You can check softlayer.com. We have blogs, tons of stuff on this available for you. Thank you.